Hello everyone, welcome back to Chemistry JRFnet. Today we are discussing questions in quantum mechanics. The first question is the difference in energy levels of n equal to 2 and n equal to 1 of a particle in a one-dimensional box is 6 unit of energy. In the same units, what is the difference in energy levels of n equal to 3 and n equal to 2? We have already discussed these type of questions, and in this question they are given the difference in energy levels of n is equal to 2 and n is equal to 1 and asked to find out the difference in n is equal to 3 and n is equal to 2. So let me start. First of all, our equation to find the energy in case of a one-dimensional box is n square h square by 8ma square. And first case n is equal to 2 and n is equal to 1. Difference of these levels are given. That is, if we substitute n is equal to 2 here, we get 4h square by 8ma square, and when n is equal to 1, h square by 8ma square. And finding the difference, we get 3h square by 8ma square equal to 6. This is given here, 6 units. And from here we have h square by 8ma square equal to 6 by 3 equal to 2. So h square by 8ma square is equal to 2. And after that, when we are substituting for n is equal to 3 and n is equal to 2, our equations become 9h square by 8ma square when n is equal to 3 and 4h square by 8ma square when n is equal to 2, and the difference is 5h square by 8ma square. And we have already find the value of h square by 8ma square equal to 2 from here, and substituting we get 5 into 2 is equal to 10. Next question, the orbiter with the 2 radial and 2 angular nodes is, and the options are given. Equation for finding the radial node is n minus l minus 1, and for angular node is equal to L. L is the azimuthal quantum number and n is the principal quantum number, and it will give the idea about the energy levels. And in this question we have given that the angular nodes is 2 angular nodes. So directly from here L is equal to 2, and we know that when L is equal to 0, we have a S subshell. L is equal to 1 means P, L is equal to 2 means D, 3 means F. So here we have a D subshell. And if we check the options, we have a 5D and 8D. So next we want to find out the value of n. For finding the value of n, we use this equation radial node. And in the equation, in the question, they are given 2 radial nodes. So 2 is equal to n minus L is 2, already we know, and 1 minus 1. 2 is equal to n minus 3, n is equal to 5. So our orbital is 5D. Next question is, a particle in 3-dimensional cubic box of A is equal to L has energy of 14h square by 8ml square. The degeneracy of the state is, and the options are given. And in case of 3-dimensional cubic box, we have the energy equation h square by 8ma square into nx square plus ny square plus nz square, and here the energy is given, so we equate this equation with the given value, and we can cancel this h square by 8ml square from each side since A is equal to L. So we cut, and our equation become 14 is equal to nx square plus ny square plus nz square. Next we want to find the suitable values for nx, ny and nz to get the value of 14. So we choose 1, 2, 3 as our number, and if we square and adding 1 square plus 2 square plus 3 square, 1 plus 4 plus 9 is equal to 14. So we confirmed that the nx n by nz is 1, 2, 3. So next our question is to find the degeneracy of the state. Then what do you mean by degeneracy of the state? Degeneracy means the number of energy levels having same energy. So we had to find in how many ways these values will give the same energy. So this can be written in 6 ways: 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. So these all will give the same energy. So the degeneracy will be 6. And our answer is option C. Next we are discussing eigenfunction. What do you mean by an eigenfunction? If an operator operates on a function f of x, we are getting the same function which is multiplied by a value. This value represented by lambda, which is called the eigenvalue, and the function is called the eigenfunction. Our question is identify which of the functions are eigenfunctions to the operator d by dx. First function is e raised to x. So d by dx of e raised to x is e raised to x itself. So our function is getting after differentiation. Here the eigenvalue is 1. Same function is regenerated here, so it is an eigenfunction. And in the case of e raised to minus x also, the differentiation will give e raised to minus x into minus 1, and the eigenvalue is minus 1 here, and this is also an eigenfunction. And moving on to the sin x. Derivative of sin x is cos x. So the same function is not repeated here. So this is not an eigenfunction. And in case of x square, d by dx of x square is equal to 2x. Here also the function is not repeating, so it is not an eigenfunction. Now we are checking the same function with the operator d square by dx square. In case of e raised to x and e raised to minus x, the second differential also gives the same value. That is d square by dx square of e raised to x is e raised to x itself, and the eigenvalue is 1 here. And in case of e raised to minus x, the second differential is e raised to minus x into 1. So here minus 1 and minus 1 gives 1. So eigenvalue is 1 here. And d square by dx square of sin x is, first we get cos x differential, and again differentiating the cos x we get minus sin x. So our function is regenerated here, multiplied by a value minus 1. So eigenvalue is minus 1 and it is an eigenfunction. Thank you all. Keep watching.